Hello, good morning, all of you. Today we are going to discuss a new topic that is called EDM, working principle of electric discharge machining. So, this machine process is well popular in the industry. So many industry equipments are available and it is used in industry as like our conventional machining process itself. As the name suggests, this process it is a thermoelectric process. Here, electric energy we are applying, and this electrical energy in its direct form is used for removal of material. So, as the name suggests, this process it can be used for electrical conductive materials only. So, this material should have a limit. A small, at least a small amount of electric conductivity is required in the material. So, then only machining is possible. But any kind of hard metal can be machined by this process. So, irrespective of its hardness, this process can be used very smoothly. It can be machined, but only limitation is that this metal should be electrically conductive. So, we know this when some sparking occurs between two switches, between two switches, when sparking occurs in switches, then small amount of material is removed. The concept actually it is used in a controlled manner in electric discharge machining process. So whenever sparking takes place between two electric conduct contacts, a small amount of material is removed from each of these contacts. This fact was realized and the attempts were made to harness and control the spark energy to employ it for useful purpose for machining of metal. So this concept actually already known to us. So some short circuit happens in between the switches and spark occurs. Because of spark, actually small amount of metal is removed on switches and that metal actually melt there itself. So this concept, same concept actually it is used for machining of metal. Okay. So in EDM process, same concept actually it is used. So in EDM process, a RC circuit it is used. RC means relaxation circuit. It is commonly known as RC circuit. So here these electrodes are actually tool and workpiece. So tool is actually uh, cathode and workpiece acts as a anode. And these two things are actually it immerse this tool and workpiece both the electrode are immersed into the dry electric fluid. Here in this figure I have shown cathode, anode, and dielectric fluid. This dielectric liquid it has a certain dielectric constant, so it is electrically neutral liquid. This dielectric liquid is electrical neutral liquid. It has certain dielectric breakdown voltage. When your applied voltage or applied potential is greater than this breakdown voltage, then only this flow of current is there through this dielectric. Otherwise current does not pass through this dielectric. So here you can see in this figure the tool and the workpiece which has to be machined by this EDM process. So you can see there is a spark occur in between these two tool, and that is cathode, and workpiece that is anode. This cathode or tool is connected to the negative terminal, and this workpiece that is anode is connected to the positive terminal. And this power supply it is connected through a RC circuit. In that RC circuit there is a capacitor. So I have shown here. So when you are applying some DC voltage, DC pulse power voltage, so voltage is around 20 to 80 volt and with 5 kilowatt uh, watt frequency. So when you are applying some DC pulse power voltage, this capacitor charges and after that it discharges. So this capacitor in that RC circuit it charges, and this whatever this uh, charge voltage is there, it discharges through dielectric in between this tool and workpiece. While it discharges, this spark occur at a minimum resistance. So minimum resistance is there where there is a inter electrode gap. Inter electrode gap is minimum. So you can see on workpiece surface. So under microscope, you will see here I have shown in right side, and tool also under microscope you will see there is a undulation are there. There is gap between tool and workpiece, and there sparking occurs with minimum resistance. This spark occur with its follows through a minimum resistance between this tool and workpiece. So it is the smallest gap between the tool and workpiece. Now, how this spark occurs? When this capacitor charges, so after sparking, it discharges and it applied a huge potential in between this cathode and anode. So this electron from the cathode break uh, loose from the cathode or from the tool. It is attracted toward the anode to the opposite charge of attracted towards the anode, which is positively charged. So there is a thousands of electrons which break loose from the anode cathode it directly towards the anode with a very high velocity. So depending on the potential you are applying through this RC circuit, so depending on capacitor discharges voltage, so this is velocity depend on how much potential you are applying in between this cathode and anode and in between this cathode and anode. Now, while coming to this traveling through dielectric, so these electrons actually it collide with the neutral molecules of or neutral atoms of dielectric. So when it collide, this electrons comes outside from the neutral molecule, neutral atoms of dielectric. Still more number of electron actually coming out outside. So many electrons actually collide with the dielectric atom and electrons. These electrons actually comes out from the atom. So there is a surge of flow of electrons from cathode towards the anode, and at the same time these ions which are positively charged is coming. So that ions are actually directed towards the anode. So there is ionization. There is a huge chunk of ionization is there. So electrons coming break loose is a hitting of electrode by these ions to the cathode, and these electron hitting of electron with a very high velocity to the workpiece. So when you apply voltage from the applied RC circuit more than the breakdown voltage, direct fluid, then actually there is spark occur. So this spark is nothing but the flow of this ionization of electrons or heating of electrons toward the anode and heating of the ion towards the cathode. Now this is about the how spark takes place. Now we'll move for the working principle. Huge flow of ions are there. So when it hits, then within a small time, maybe thousands of seconds in a microsecond time, so this sparking occur. So because of this sparking, molten metal, this spark occur into the small area, into the micron, small micron, or micron area. This sparking occur through way because of this sparking. So material there on the materials workpiece surface melt and vaporizes, and at the same time because of this heating of ion also metal from the tool and melt and vaporize. Okay, so there is a machining from the tool as well as from the workpiece surface. So because of This melting huge amount of heat is generated there. So because of this generation of heat, of this much of heat into small area, we are considering only a single spark. We are considering into small area, huge amount of metal is molten. It comes into the molten state, or it comes into the vaporized state. So this much amount is removed from workpiece surface because of this heating operation. So it's from a scatter from workpiece. So this hemispherical scatter are actually generated because of single spark from this scatter. And it is very less, maybe 1.2 to 1.5 micron, and this depth, this diameter of this scatter is around maybe 10 micron. So this much small scatters are generated for a single spark. So when thousands of spark is generated in a 1 second, because we are applying the power supply with 5000 hertz frequency. So this 5000 spark are generated in 1 second. So many scatter are generated on the workpiece just below the tool. So these scatters are actually distributed over the workpiece, and minimum distance, that is a minimum gap is there in between tool and workpiece. So these scatters are distributed over the all the work surface. Okay, so below the tool. So whatever the replica of the tool, the same replica of the tool is generated into the workpiece surface. So this because of this EDM process, you will get where whatever tool depend on your tool specification or tool shape, similar shape will be generated on the workpiece surface. So any kind of complex shape can be generated. Any kind of complicated shapes can be generated by this EDM process. So this tool and workpiece both, everything is actually it is emerged into the direct fluid. So this machining actually it goes on into inside the total tool and workpiece, everything it is immersed in the direct fluid. So machining occurs inside the direct fluid only. So you can see here I have given in short working principle of EDM process. Okay, this is about the today's lecture. Thank you.